Right, question 22. However, I'm just going to quickly go back to question 21 just to say, right, I don't think I explained it very well at all. Explain why Yusuf would not use application-based testing as a measure of performance, processor performance, and that's essentially because, application-based testing, okay, it also takes into account other aspects of the system, such as your data bus width and your cache memory, okay. So that's just to do a wee recap, and that was part D, part 2. Right, so the way I explained it last time, it didn't quite make sense when I looked back at it, okay? Right, but if we go back to question 22, right? So it's asking you system analysis is trying to find exactly what's required of the system, and they're having problems when they're interviewing people, okay? So obviously that's a method the system analyst uses, and why might folk, or why might they have problems with it? I mean, not everyone wants to cooperate if they're getting interviewed, okay? So some of the staff might be unwilling to give answers. Also, they might start rambling about irrelevant information. And or they might actually be giving inaccurate feedback. Okay, so they might be assuming they know more about the system than they actually do. Okay, so and I mean there's a lot of different answers as long as you can justify why you're saying it. But there's kind of three main ones. So some folk they don't want to be talking to others, and it might be irrelevant and inaccurate information. Okay. Next one is when designing, use top-down design. So remember, this is when you break the problem down into small wee parts to solve the problem. So you break it down into smaller wee chunks. If it asks you for stepwise refinement as well, which is the natural progression, these parts are then breaking down into even further down, so into kind of negligible parts, okay? A word I can't even say, right? But top-down design, problems broken down into smaller parts, and it just makes it easier to solve, okay? Right, question C, well, we're looking as a nice wee interface. Now, if you actually see something that's involving buttons, quite often you're looking for event driven because each button can launch a bit of code, and these launches are like events, really. Okay, so these are like the objects onto it, and they're basically saying, state the two reasons why the event driven language has been chosen. Okay, well, it does with this, you use Visual Basic, it allows you to actually trigger the launching of different chunks of code when you click on a button. Okay, and the order of execution of these chunks of code is decided by the actual user of the software. So basically, if they want to view all the classes, clicks there, it then triggers the launch of that piece of code. Okay, and it's actually you're deciding what order it's launched. So it's not read from the very top down to the bottom. It can be you might launch it and edge straight away, exit it, or launch it and view the classes, you might not be booking it. So that's why event driven is good for that, because basically it allows your sections of code to be triggered by like something like a button, and the order of how these sections of code are actually executed, well, that's decided by the person using the software. Okay. Team of programmers starts to create the code. Explain one way the team can efficiently work together to create the code. Right. So if you break down the code into using top-down design, break them down into wee sub-programs, okay, you can each have a sub-program, and you could be working alongside another programmer working separate sub-programs in parallel with each other, and that just reduces implementation time. So many hands make light work, as they say, so programmers each work in individual sub-programs, and that just reduces the overall time. So it's not just one person having to solve one sub-program, then program another one, then program another one. You can be working at it, and it's like building a house. You might have somebody doing the plastering, somebody else is in another room wiring, right? So it's something in which programming, you will have a team generally, and you can all be working in different areas of the program, and you've got a time constraint anyway, so that's the way you'd want to do it. If we then look at systematic testing, well, if you're systematic, you've got a wee plan, right? You're very methodical, and that's the same with that type of testing, okay? So you basically you follow a plan. So you would do that. You'd create a wee test table, knowing your normal, extreme and exceptional data, and you're doing that systematically. It's a wee method behind your testing, and that's all systematic testing is. Okay. And the final version of software is translated using a compiler, and its compiled code is distributed to other offices. So remember, with a compiler, once it's translated, you no longer need that translating software. Okay, so remember, any software you're actually running, it does take space up in your memory. So once you've actually got it compiled, you no longer need that translator. Okay, and that's what they're really looking for. Okay, is it is more memory efficient because the software is not held in the memory. Okay, so you don't have, if it was an interpreter, every time you ran it, you still need this wee translating software held in the memory to translate it. Okay, so that's why once it's programming, which it is working, you use a compiler. Right, let's do this. Well, state two characteristics of well-written codes. Well, internal commentary, so let's remember, that's where you put your turns a line green, so it's comments that the user can see. Okay, internal comments. It's pretty bizarre spelling. Right. Internal comments, you can use white spacing, right? And you can use indentation as well. Have good descriptive variable names. So you want, if it's storing an age, have a variable name called age, because that describes what the data is going to be held. Okay, but that's, I mean, there's a few other ones as well. Two reasons why portability software is important, okay? Obviously, if you've got software that can run on different computer systems, you've got a bigger market, so you can make more sales. And also, if it can run in different computer systems, you're not having to go back to modify it to run in these systems. So it reduces you having to work in another implementation for a new platform. Okay, so you're really wanting software that can run in any computer system because you're not having to redevelop it for another system, and you're going to make more money, right? So you just need to work in implementation to a new platform, and this increases sales because you've got more platforms available, so more money then. And the last one, asking after several months, the council would like to include a management booking option. What type of maintenance? So it wasn't in the original specification. So it's an add-on, so that's Perfective. So they do have to actually pay for that. So it's Perfective. Features not in the original software. And you'll have your software specification to point that out, okay? But that's Perfective maintenance. And that's end of question 22.